Hi class, we are starting chapter 12 and we're going to be looking mostly at 12.1 and 12.2. We're going to discuss the intermolecular forces that hold our liquids and solids and gases together for the so that they have the properties and behaviors that they have. So when we look at water, it tends to be spherical in shape, and water is a very good example of the intermolecular forces and how water, those forces change water over everything else that is in its same molecular weight. For instance, we'll come back to water, but the molecular weight of water is 18.02 grams per mole. Anything else that is in the same molecular mass of that, they're all gases, yet water is not a gas at room temperature. And that has to do with these intermolecular forces that we're going to be discussing in this section. It's way different compared to everything else. And thank gosh it is, because we definitely need water and we need it as a liquid. So what are intermolecular forces? These are the forces, these attractive forces that exist between the molecules. So between the water molecules that hold them together as a liquid. We need everything, our whole existence is dependent on intermolecular forces. And, excuse me, so they are responsible for the existence of liquids and solids as we know them. So properties of liquids and solids. Gases, which are molecules or atoms, are separated by large distances. I'm going to do a review on some of the slides on another chapter in case any of this may have been forgotten at this point. But in a few slides coming up. So molecules or atoms, they compose of gases. Gases tend to have very large distances between each other. They really do not want to interact with each other. There is no strong forces to keep them together. Unlike liquids and solids, which have stronger attractions to each other, which keep them together, and depending on that attraction, that'll either determine whether it's a liquid or a solid. So the difference between solids and liquids is the freedom of the movement. In liquid, they have way more freedom to move around. They are still attached, but they have a loose movement to them. Where solids do not. They are fixed position. They cannot move out of those positions. So the only thing that they can do is vibrate from that fixed point. So again, I pulled these slides. These are my slides from, and they're a little blurry because I had a problem transferring them over. But there's three physical states. There's solid, which has definite volume and shape. Liquid, which has definite volume and the shape's determined. And then we have a gas that the volume and the shape are both determined. So solids have a definite shape. They will not take up the shape of a container. They are fixed in whatever that shape is. And they also have definite volume, meaning you cannot compress them down. The particles are very close together and they are in a fixed arrangement, which you cannot change unless you break it. The particles move very slowly, and that's because they are in a fixed spot. So they're stuck in that spot, and the only thing they can do is vibrate. And if the vibrations get too strong, eventually it will break. And so you can see here's an example here is of an amethyst, which is a solid. So there's different types of solids, and we have crystalline and we have amorphous. Crystalline is very patterned. It has the definite repeating pattern to it, and they're usually very long, and those patterns don't change, and that gives crystallines those nice crystal looking, when you think of how maybe if you've ever looked at salt up close, it's got like a shiny side and stuff. It's got a definite repeating pattern to it. Amorphous does not. It's more disordered, and because it's disordered, it doesn't have those those long repeating patterns to it. So you can see here where this is very well ordered. There's no particular order in how this is. It's extremely disordered, well ordered, disordered. So here's a crystalline solid. So here's a picture of a sodium chloride, and you can see it's kind of like, it looks very, compared to something like amorphous, excuse me, you can see it's got even little shiny sides to it. So it's very well ordered, well patterned, and these long repeating chains. Liquids, on the other hand, have an indefinite shape. So they can take the shape of whatever you pour them into. So if you think of water can go into one container and fill it up to a certain point, and then it can go into a different type of looking container and it will take that shape as well. So liquid has these attractions, but they're not as strong as a solid, these intermolecular forces, because they will take the shape of something. So they're more flexible with that. The particles are still close together, so they are in contact with each other, unlike gases, but they are able to move around more. And the particles move slowly because they are still connected to each other. Gases have no definite shape and no definite volume. They will take, they will consume whatever room or container they're in until they hit resistance, because they are moving at very fast speeds. So they will just keep going till they hit resistance, bounce off, and then go back. So that's why if somebody walks in a room, a very large room with perfume, you will eventually smell it if you're on the other side, because it's a gas. And those molecules are traveling very quickly, and they're going to keep going until they hit resistance. So they will take they have indefinite shape and indefinite volume. They will fill a container as much as possible because they are very far apart from each other and they move very fast. And they don't have, and one of the key things I should say, they have weak intermolecular forces compared to liquids, which liquids have moderate intermolecular forces, and solids have very strong molecular forces, and that's what keeps them together. So it's all based on the attractions to each other, which determines what they are. So in this case here, this is from another book, but I like this table more than what your book gave you. This gives more, it breaks it down a little bit better than what your book actually gave you in table 12.1. So this gives just more information to tell you about it. Movement of particles, very slow. So again, solids have very strong intermolecular forces. Liquids have moderate, and gases have very weak intermolecular forces, attractions, because they're not attracted to each other. They're trying to stay away. So again, this is just kind of repeating itself. Liquids have freedom, but they're still attracted to each other. They can move, so they have moderate intermolecular forces, attractions to each other. Solids vibrate, but they cannot move from that spot, or they break